Mountain road construction explained. Challenges, alignment, and engineering logic. Mountains look calm from a distance. Silent, massive, unmoving. But for engineers, mountains are never still. Gravity is always working. Water is always searching for a path. Rock and soil are slowly responding to stress and time. When a road enters a mountain, it enters a system that never sleeps. One wrong decision may not fail today. It may not fail tomorrow. But after rain, after traffic, after years, the mountain remembers every mistake. That is why mountain roads are not ordinary roads. They are long-term engineering negotiations with nature. In this episode, you will learn how mountain roads differ from plain area roads, why rain becomes the biggest challenge in mountains, why valleys and natural water paths are critical, how engineers select alignment in mountain terrain, why engineers sometimes choose bridges, why tunnels are introduced, how engineers control gradient in steep terrain, and what happens when alignment ignores the mountain. At the end, you will see a preview of the next episode, where we go deeper into rain and drainage systems. Everything is explained clearly, within less than 10 minutes. Come, let us begin our journey into mountain road construction. Do you want to learn the real secrets of civil engineering, the kind of knowledge most experienced engineers never share? Welcome to Civil Guru Solutions. This channel is dedicated to revealing the hidden side of civil engineering and explaining it in a simple, practical, and easy-to-understand way for everyone. Here, you will explore every stage of the profession: design, quantity surveying, estimation, scheduling, execution, and quality control. To make learning accessible worldwide, our videos are available in multiple languages: English, Spanish, French, Portuguese, Arabic, Hindi, Tamil, and many other international and regional languages. You can choose your preferred audio language from the YouTube settings at the bottom of the screen. If you find our content helpful, please like, share, comment, and subscribe. Thank you for being a part of Civil Guru Solutions. Together, let's learn, build, and succeed. Why mountain roads are different? How are mountain roads different from plain area roads? In plain terrain, roads are built on the ground. In mountains, roads are built by cutting the ground. That single difference changes everything. In mountain terrain, natural slopes already exist. Gravity is always acting. Water flows rapidly downward. Soil and rock may be fractured or weathered. Here, the ground is not waiting to support the road. The ground is constantly trying to move. That is why mountain road engineering is not just about design. It is about risk management. Engineering solution. Engineers respond by studying geology before geometry, respecting natural slopes instead of fighting them, designing alignment that minimizes disturbance, and planning drainage and stabilization before construction begins. Mountain roads succeed when engineers design with the mountain, not against it. Rain and slope instability. Why is rain the biggest challenge in mountains? Rainfall in mountains behaves very differently from rainfall in plains. Water does not spread slowly. It concentrates. It accelerates. It penetrates slopes. Rain infiltrates soil and rock, increases pore water pressure, reduces shear strength, and activates hidden underground flow paths. Many mountain road failures do not occur during construction. They occur after rainfall, sometimes years later. Engineering solution. That is why engineers treat drainage as a primary structural system. Avoid alignment along uncontrolled flow paths. Provide early interception of surface and subsurface water. And design slopes assuming worst-case rainfall, not average rainfall. Rain controls almost every decision in mountain road design. Valleys and natural water paths. Why are valleys and natural water paths so critical? Mountains are full of natural drainage paths. Valleys, gullies, and depressions carry water. They carry debris. Sometimes they carry entire slope material. If a road blocks these paths, water pressure builds up. Flow diverts unpredictably, and slopes and structures become overloaded. Engineering solution. Engineers preserve natural drainage crossings. Provide culverts, bridges, or open channels. Design for debris movement, not just water flow. And never force water to change direction unnaturally. That is why drainage crossings are not optional elements in mountain roads. They are survival systems. Alignment decision. How do engineers select alignment in mountain roads? In mountains, the shortest route is rarely the safest route. Engineers carefully study natural contour lines, ridgelines and spurs, valley crossings, landslide-prone zones, and existing drainage patterns. The fundamental principle is simple. Disturb the mountain as little as possible. That is why mountain roads follow contour alignment, use winding paths, and avoid deep vertical cuts wherever possible. Alignment selection is not geometry alone. It is geology. It is hydrology. It is engineering judgment. Bridges and tunnels. Why do engineers sometimes choose bridges? Following the terrain often means long descents into valleys and long climbs back up. In deep valleys, engineers may introduce high-rise bridges to connect one mountain directly to another. Although bridges increase project cost, they reduce travel distance, save travel time, reduce fuel consumption, improve driver comfort, and reduce accident risk. Bridges are chosen not just for construction feasibility, but for long-term safety and performance. Why are tunnels introduced? In some locations, cutting the mountain is dangerous. Edges may be unstable. Slopes may be too steep. Following the contour may add many kilometers of risky road. A short tunnel can replace long stretches of dangerous alignment. Tunnels avoid unstable slope cutting, improve construction safety, improve long-term road safety, and provide smoother and faster travel. Mountain alignment is not about cost alone. It is about safety, comfort, and durability. Gradient logic in mountain roads. What is vertical gradient? Vertical gradient is the slope of the road along its length. It defines how steep the road climbs or descends. In mountains, gradient is dictated by terrain, not convenience. How do engineers control gradient in steep terrain? Contour alignment is the primary tool. By following natural height contours, engineers spread elevation gain over longer distances and avoid steep climbs. That is why mountain roads appear longer than straight line distance, curve frequently, and change direction many times. These curves are not design flaws. They are engineering solutions. Why are hairpin bends necessary? Hairpin bends are not poor planning. They are engineering compromises. Without hairpin bends, gradient would exceed safe limits. Cutting height would increase drastically, and slopes would become unstable. Hairpin bends control gradient, reduce cut slope height, improve slope stability, and maintain vehicle safety. Each hairpin bend represents a balance between geometry, geology, safety, and constructability. What is a comfortable and permissible gradient in hill roads? Based on standards such as IRC, AASHTO, and British standards, and global engineering practice. For comfortable and safe travel, mountain roads are generally designed with gradients, around 4 to 5%, where terrain becomes more difficult. Gradients may be increased to 6 to 7%, but engineers treat this as a limiting condition. At unavoidable locations such as hairpin bends, gradients may briefly rise to 8 to 10%, but only for short stretches, and with careful safety considerations. As gradient increases, vehicle control reduces, and braking demand rises sharply. That is why gradient control dominates alignment planning in mountains. When alignment ignores the mountain, when alignment ignores gradient limits, natural drainage paths, or slope stability, the mountain responds not immediately, not dramatically, but slowly. Cracks appear, drainage systems clog, slopes weaken, and one day, often after heavy rain, the road fails. Mountain roads rarely collapse suddenly, they fail progressively. We now understand why mountain roads are fundamentally different, how engineers select alignment, and how gradient governs safety. But all these decisions are controlled by one dominant factor: rain. In the next episode, we will go deep into rain and drainage systems in mountain roads, how water moves, how engineers control it, and why most failures begin with poor drainage. Because in the mountains, water decides whether a road survives or disappears. If this episode changed how you see mountain roads, you are already thinking like an engineer. Subscribe to Civil Guru Solutions. Here, we do not just explain how roads are built. We explain why they survive or fail.